All right, Chapter 9, Test 1, Review Sheet number 2. Question number 1. Find the measure of the arc cut off by a chord, 30 centimeters long, and a circle of radius 22 centimeters. So here is my chord, AB. And I want to find the measure of arc AB. That's the question. So first of all, I'm going to go from the center. I'm going to draw a radius perpendicular to that chord. And that's going to do two things. One, it's going to bisect the chord. And it's also going to bisect the arc. So now I have two equal arcs, arc AX and arc XB. The radius is 22, so yeah, it's true that OX is 22, but it's not going to help me solve the problem now, is it? But OA is going to help me solve the problem. If I make OA 22, then I can find the measure of arc XA, arc XA, arc AX. Let me call that Y. It's in degrees. I can find Y because an arc is equal to its central angle. This becomes a trig problem. So I'm going to use SOHCAHTOA to figure out X. Alright, so I have, in relation to Y, I have an opposite side and I have a hypotenuse, opposite side, hypotenuse. So I'm going to have sine of Y degrees equal to 15 over 22. 15 over 22 is equal to 0.6818. I need to take the inverse sine of 0.6818, and that will give me 42.9 degrees. I guess I could call that 43. It's that close. Double that, and the arc is 86 degrees. Question number 2. Circles P and Q have a radius 16 and 9 respectively. They're externally tangent to each other. Find the length of the common external tangent segment, which is going to be about there. Let's call that AB. Circle Q is the smaller circle. It has a length of 9. Intersects the tangent at a right angle. And circle P has the larger radius of 16. Radius perpendicular to a tangent theorem. Since the two circles are externally tangent to each other, the line of centers is continuous. So 9 plus 16 is 25. 9 plus 16 is 25. The key to this problem is to start at the center of the smaller circle, draw a segment perpendicular to the larger radius, creating a rectangle and a right triangle. There's my rectangle right there. I want to find the length of AB. If it's X, then its opposite side will be X. Likewise, if QB is 9, its opposite side is 9. 9 plus 7 is 16. Now I can use Pythagorean's theorem. I have 7 squared plus x squared equals 25 squared. Some of you may recognize that that's a Pythagorean triple, 7, 24, 25. If not, that's okay. If we square that out, we get 49 plus x squared equals 625. If I subtract 49 from both sides, I'm going to get x squared equals 576. Square root both sides and I get 24. All right, that's question number 2.